So, jumping in to our first step, which is establishing interest. And this is pretty much just like it sounds. We all know that the more interested we are in something, the more likely we're going to spend our time or our energy on it. And for kids, they're just beginning to figure out the world and they're naturally quite curious. The goal that we have is, and that we together working with parents have, is to encourage that curiosity and offer them the tools that they need to really explore what they're interested in. Establishing interest will serve to spark curiosity and intrinsic motivation, which is what we're really going for. The intrinsic motivation referring to a student engaging in an activity or a person engaging in an activity because it's inherently satisfying and enjoyable rather than for external rewards or pressures. Our goal at this stage is to encourage play and exposure to a lot of different concepts or different things they might be interested in, but not to add too much pressure. This is why our early core classes have homework and classwork that are focused around building games and fun projects, and why a lot of coding classes, especially for younger students, are based on gameplay or making content fun or flashy. And there's a lot of benefit to that as long as students are also getting the foundational principles as well. So we know what interest is, and we may know our own interests, but how do we find, establish, and nurture interests within our students? This can begin with a link between programming and something that they already really love, like Minecraft, games, arts, or robotics. Or you're really lucky.
Kelsey, there are people are saying they can't see your slides, but actually I can see what you're
Is this better?
sharing.
It should be on establishing interest now. I think maybe it was paused. There we go. Okay. Perfect. Everybody can see
Okay.
them. Okay. Sorry about that, guys. Thank you for letting me know. I think that my slides were paused. So first slide is just establishing interest. This is what we were talking about. You didn't miss anything too big, but I'm glad. Thank you guys so much for letting me know. But now we're here on this establishing interest slide. So we're figuring out how do we find, establish, and nurture that interest within our students. Like I said, it could be something that they already really love that has a coding aspect to it, especially if we're really focused today. My primary focus is going to be coding and computer science. A lot of these concepts can be applicable to lots of other avenues for students, but today we're focusing primarily on coding. Or you're already pretty lucky and your student is really excited about exploring CS, and your main goal then is just kind of preparing what different things they'll be exploring. How we establish interest and how we encourage parents or other people to establish interest. Like I said, the game and project-based learning is really important for students, especially young students. Using coding as a vehicle, not a destination. Keep in mind that we're all kind of consistently students, and especially in the world of code, depending on what different avenues your students would like to try, whether that's front-end development, whether that's back-end development, whether that's going into the medical field and doing research. It can be a ton of different things. And coding, you'll never arrive at being a perfect coder. I think that it's consistent work, and the code is a tool or a vehicle. It's not something you arrive at. We work with parents and students, and I think parents and students, you two working together as well, is another key component because here we also encourage obviously asking students a bunch of questions like what gets your student excited or where does their curiosity naturally show up. I ask a lot of parents in our parent meetings what kinds of classes they're really excited about, or what external projects you see them sinking a lot of time into. Being able to recognize interest and foster it is one of the key components and the first steps in order to get them to that intrinsic motivation. You can also showcase fun starter activities so that students can get excited and then build to those more self-led projects. Finding out from your student what they're interested in direct from the source is always going to be the best way to figure out what types of long-term goals they have to make or what the student will be able to do with the material down the road. Once you've established the interest or at least found the interest, it's important to develop your toolkit. The goal here is to build foundational skills and confidence. because we've already established interest and we have that little bite, but now we need to establish those skills and continue with building confidence. The goal here as well is for students to gain autonomy with coding, understand the structures of computation, and begin to take the lead on creating projects for themselves, others, or their communities. You should think of coding sort of like learning a language or an instrument. It takes time, but every step can build momentum. Our early lessons will generally focus on logic, sequencing, or syntax. And we utilize beginner-friendly environments, and you can always find quite beginner-friendly environments available all over. This can be anything from our Java blocks to Scratch, and then utilizing Python or Java. But the most important step in developing a toolkit is time. And that's something that we don't always have a ton of, but spending time on the material and practicing with the concepts are the only ways for students to actually develop a toolkit. Students at this age, anywhere from 7 to 18, aren't always going to be the best timekeepers or time managers. So parents can really help here by supporting their kids in finding regular practice times, encouraging persistence, and really getting curious about what their students are learning. I can really promise you that there's not a better way to learn about variables or if statements than from a budding 10-year-old who's just learned about them. So what's in this toolkit? This isn't a regular run-of-the-mill toolkit. You won't find any drill bits, loose screws, or hammers. Some of the key things you're going to find, or hopefully develop, are foundational understanding of how to code. This can be developed obviously through the use of classes, research materials, resources on the internet, and lots of other options. Some key skills in the kit could be debugging, problem solving, and pattern recognition. And a big lesson that should be learned or will be learned is that mistakes are a large part of learning. And that's something that as parents, it's super helpful if you can reinforce, because students participating is more important than students being correct. Keep in mind that developing this toolkit is going to take time, and each new topic a student learns is basically just another tool in their toolkit for a project, a problem, or any other purpose that they'd like to use it for. As your student is developing this toolkit, and as you're as we'll talk about, developing the path for your student, you want to keep in mind that this is individual. So while it's really useful and so helpful to have input, and we'll talk more about that later, keep in mind whether your goals are long range or short range, and make sure you're picking out the best tools that your student will need for whatever goals they may have. Coding is just a tool in computer science. This can help students solve algorithms, data structures, and logic, but being able to truly develop a skill also comes with having the goal in mind and preparing and moving toward the goal. In order to do that, we'll need to choose a path. The real objective in any case is to align students' interests with any long or short-term goals that you have as a family or as a student individually. Students can obviously utilize courses from lots of different paths, and these specifically are Katie Byte paths. So whether you're inside the proverbial walls of Katie Byte or outside, you have lots of opportunity to pick which academic opportunities your student has access to, whether it's classes, personal projects, community leadership, or our hackathon that's coming up on June 7th and 8th. So make sure to sign up if you haven't. Or whatever your student's heart fancies, there's a lot of different pathways that parents can go down. So these are our 4 paths. I'll explain them briefly. The exploration path allows students a chance to explore the various applications or the various different areas of computer science in Katie Byte. This one, Jeff will take you through like generative art. It can use game design. Application track will take you through different things like software development, potentially, if that's something you're interested in. It could take you a little bit into competitions, but it's more focused on a broad smattering of different applications within computer science. The accelerated track is focused on mainly students who are looking to get to and through the AP Computer Science A exam. And the competition track is focused on those who really love to problem solve and they really want to compete. And I can totally assimilate with those individuals because I also love to compete in different areas, but I also love art and different applications in that area. So keep in mind that choosing a path doesn't mean that you're only going to pick that one path. It's just a way for us to organize and provide more information in a clear and cohesive way. So if you are a parent at Katie Bite and you haven't already selected a path, please do so. It just allows us to send you more information. And if you're completely outside of Katie Bite and this is all quite foreign to you, keep in mind that these paths don't have to be mutually exclusive. It's mainly just a method for us to figure out what your long-term goals are so that we can provide you with more information about those different goals or opportunities that can help push you toward your goals. The last step, and it's broken down into three sort of subsections, is turning our plans into results or reality. This is where coding becomes a practice. Students can take on challenges, build projects, or even compete. It's basically the action step after choosing a path. We want to support students' growth, help them set long-term goals, and potentially build a portfolio down the line. The key requirements are staying informed, being able to understand opportunities, and leveraging your learning. We did just get a really good question. Does the teacher guide us how to progress at Katie Bite? And at Katie Bite, the answer is yes, as well as operations. So you have two sets of people who are here to help give you the most information as possible. Instructors at the end of each semester will provide you with a final recommendation for a class, and this will include all of the classes your student can take next. And this is where your pathway will come into play. If you've selected a path, the instructor can see that and then potentially select more electives or different classes that are hopefully gearing in the direction of your path, as well as operations. And then once you get that email, it will have links to all of the classes and you can choose from there. We'll also have feedback from previously in the semester, and they'll tell you what you're capable of moving on to, and it's kind of up to you to decide which class you'd like to move on to next. If you have more questions or want me to go a little deeper, let me know in the chat, but I'm going to keep moving on. So staying informed, understanding opportunities, and leveraging your learning. The first step is staying informed. You don't know what you don't know. And when it comes to coding for students aged 8 to 18, I can tell you it can be a lot. As a parent, staying in the loop helps you to guide and support your students' growth. For us, I know that I am almost constantly Googling for various opportunities. Yuhua is the leader of our competitions department, so she is on top of all of the competition opportunities that we are able to be a part of, and we truly do want to be able to provide the most information and the most opportunity to the most of our students. And so ways to stay informed with us specifically is to sign up for our newsletter. It is a really good newsletter, in my opinion. Ihua also helps us to make that. And we all come together, put in some notes, and kind of try to figure out what is the most important information, and then always try to add something for Katie Bite students to either get involved in, whether it's local to a certain area, or whether it's not region specific, but available to anyone. Attend parent seminars like this one. There's this one. Other companies host their own as well. The more information you can get, the better. Ask your student what they're learning. Your student being able to articulate to you what they're learning can really, really help them to solidify the things that they are actually working through anyway. And keep in mind that we host a blog, and a lot of our student features are on there, which can not necessarily always answer questions, but they can give you an idea of what students are even doing with this. A lot of times it's hard to make the connection between a young student who's learning to code and a student who started their own company, utilizing what they've learned, or a student who's gone to college and maybe didn't go for CS but went for biomedical engineering and really appreciated having the background. In order to understand more, you have to hear more stories about it. And so we do try to post as many of our student stories as we're able to, but keep in mind that there's lots of options out there. Um, and the best way to learn about them is staying informed through various different outlets, as well as knowing what's out there and what your student is learning will allow you a better litmus for telling when your child is ready to level up, take on a new challenge, and be there to support them when it's time. The second step here is understanding opportunities. There's so many different directions that coding can take, and it's important to understand what's possible so that you can help your child find their path. Some examples that are pretty simple that you probably know about. And I did see a lot of selecting competitions, skills, just general skills was a big one in the entry survey. So thank you everyone for filling that out. Competitions was big, and competitions is always big. It's a really great way to show what you've learned. It usually will come with something that's easy to put on a resume or put in your portfolio. Other things are personal projects or mentorships, taking advanced classes or college prep like APCS or dual enrollment or even online programs. Even short-term experiences can help boost students' confidence. Like building an app, making a game, or coding a tool for school can help students utilize what they're currently learning in a setting that instills confidence and allows them to take on leadership. And as you're thinking about what opportunities you might want your student to take on, you can ask what opportunity might my child enjoy or benefit from next? And then keep an eye out on our newsletter or on various different newsletters and see which ones you can sign up for. Lastly, leveraging your learning. Learning is the first part and applying is the second. Learning is great, but without application, the knowledge just won't stick. This is also a big reason why our classes are formatted the way that they are. Core classes 1 through 6 are organized in two key sections, the A levels and the B levels. And generally, the A levels are for knowledge and learning. It generally will include more lecture-based or more direct learning. And the second level will still have some of the lecture-based material, but we'll have a much heavier focus on projects and independent application of concepts. So keep in mind that this sort of concept of how students understand and how they can use what they learn is also baked into our curriculum. On the outset of learning what they can learn, using it as a tool, and then utilizing it externally, there are a few tips that you can think about when you're trying to leverage your learning, but you're not really sure what direction to go. Encourage project creation. Offer suggestions for problems you'd like to see solved or help come up with ideas for your coder to create. I've done quite a few parent and student internship or parent and student interviews. And a lot of what I hear from students that really made coding stick for them was their parents being involved, whether they were a coder by trade or not, um, asking questions, getting curious, and offering suggestions, even if they're making a game. It could be colors, it could be the way the characters move. The more that you can invest there, I really do think that pays off in the long run. Think of Think about a portfolio once your student starts getting into typed code and making larger scale projects and what you may want that portfolio to look like. And then participate, participate, participate. Learning is really great, but participation is what really will get students to the next level. The more that they're talking in class, the more that they're asking questions, the more that they're trying to give an answer, even if it's not necessarily the right answer, the more we see them move through and do really well with material. The real world application is going to be what builds confidence and allows for more independence. The portfolio, like I said, is a record of projects, competitions, or certifications. This is going to allow your student to quantify what they've done with code and what they have learned or what they are capable of doing. You can support your students as well by helping them reflect on what did I learn and what would I do differently next time if they're struggling with a game or if they didn't really love the last project they made. Remember that as parents, you guys are there to be cheerleaders, an accountability buddy, and a guide. Even when you might not understand the code, a lot of code has to do with logic, and that's something that a lot of us are able to help with. So I want to work into just a few of our Katie Byte FAQs. This will be mostly me reading because they are question and answers that I've already listed out here. But if you have questions that you'd like answered that I haven't already answered, please feel free to use the Q&A, or you can go ahead and use the webinar chat. But I'm going to go over these Q&A questions, and then I'll leave the floor open for about or actually, we have one more section, and then I'll leave the floor open for about 5 minutes, and we'll go through any parent questions as well. So my child is brand new to coding. How do I know where to start? So obviously, in general, you want to start by sparking curiosity and establishing that interest. There's lots of different exploratory or beginner-friendly tools. There's Scratch. We teach a Scratch class. There's also Scratch is just open source. It's on the internet. You can use it. A placement or trial class can help us recommend the right level or path for students. That's how we generally will start, just to make sure that they're in the right spot and getting the right amount of support as well as the right amount of challenge. How do I know if my child is progressing or doing well in coding? Progress can look really different for every student, and also it's really hard to gauge progress when you don't understand what they're learning in general. Some students are going to move really quickly through the material, and others are going to dive deep into projects. Increased independence, curiosity, and the ability to explain what they're working on can be some key indicators that your student is progressing and they are doing well. And keep in mind that at Katie Byte, a lot of times students will advance beyond the regular stages and already be doing advanced coursework at pretty young ages. So if your student's already taking class with us, they're already advanced and doing well. And if they are not doing well, then you'll get an email, we'll let you know, and we can always work to help make sure students are getting the support they needed. Should my child be doing competitions? This is a question I get all the time. Or what competitions? Or should we do USACO? Should we aim at USACO? Competitions are a fabulous option for students, but they have to enjoy challenges and enjoy problem solving. They're not for everyone. So we recommend them when students will feel confident with their core programming material and they'd like to go further. This just means that you have to have an established base. This is already after interest has been established and you've already been walking on the pathway to build that foundation in code so that you already have the tools. We don't want to send somebody into something unprepared because a lot of times that can cause a big hit to your confidence. So make sure that your students are excited about it. And if they're not super excited about it, you can always try lower level competitions to build interest or at least build some confidence before shooting for higher level competitions like USACO. What should a coding portfolio include? Anything your child's created, from small games to class projects, independent work, even screenshots of cool ideas. This portfolio can be very rudimentary, especially to start if you want to save the information. It can be just like a folder too, if most of what your student is doing is also comes with either a physical certificate or a PDF version of a certificate. A folder on a computer would work well as well. And then all of your students' projects will be saved on the Katie Byte website and they can access them pretty much whenever. As long as you keep your account, login and password, you can see the projects. How involved should I be as a parent? You don't need to know how to code. I can promise you that. The main role here is encouraging exploration, helping to celebrate milestones so that we can continue working together to really build the more confidence and excitement there is around something, the more students will want to do it. And then you can help your child carve out the time and space they need to practice regularly and establish good homework habits. What are the long-term benefits of coding even if your child doesn't decide to become a software engineer? Coding can build critical thinking, creativity, persistence, and a lot of technical literacy. Obviously, with the tech world changing and flowing, AI is coming. What does that mean for things? In general, the core concepts that we teach are explaining to you how a computer thinks, and it really gives students a lot of fundamental skills on how to think and work through solving problems and understanding what the variables are. There's also a lot of links with math and other, as well as other courses in school. So keep in mind that even if your student isn't going to become a software engineer, there's still a lot of benefit that they can get from any level of coding education. Scheduling. The summer semester is going to start after our spring classes wrap up the week of June 20th. Our summer schedule is posted. I'll add a link into this before we send it out as a PDF, but you can just go to katiebyte.com/classes and use code KTSPRING25 for 20% off your spring enrollment. The formats for the summer are 18 lesson hours generally. The summer options are 2 times a week, 3 times a week, and 5 times a week. Not all of them will be offered for all classes, but that's in general the structure we tried to keep. There will be week-long core and robotics classes, as well as some 12 lesson hour classes closer to the end of the summer. I will open the floor for anybody who might have questions, comments, or concerns, and you can feel free to post them in the chat. Or if you'd prefer to speak, let us know in the chat and we can make it so that you can speak as well. But that's everything that I have for today. Thank you guys so much for listening and going through the material with me. If you want me to go back to any slides, just let me know. Otherwise, I saw that the exit poll was released. So if you are here, please take just a few minutes to fill out the exit poll before you hop off. Otherwise, thank you so much everyone for taking your time to spend it with us and talk a little bit about kids and coding and hopefully getting them excited about coding and providing them with great opportunities as well. So feel free to ask questions in the chat. Finish the exit poll if you haven't already,